Section 7.4, factoring difference of two squares and perfect square trinomials. A difference of two squares is a problem that has two terms only. Looking at example A through example F, those problems have two terms, and so those are possibly a difference of two squares. Let me explain quickly. Difference of two squares is essentially a subtraction problem where the first term and the second term are squared. When we factor, we write two parentheses. We write a times a, that gives us a squared, and b times b gives us b squared. The signs will be opposite. That is the formula to factor a difference of two squares. Let's look at the examples. Example A, you have the first term squared, a subtraction sign, and then the number 100. 100 is what number squared? It's 10. So when we factor, y times y, opposite signs, and then 100 breaks up into 10 times 10. And that would be our final answer. Example B, same idea. We have two terms, we have a difference. 16 is 4 squared, 9 is 3 squared. This is a difference of squares. We can factor it. So 4x minus 3, 4x plus 3. It does not matter which of the factors you write first. I can write 4x plus 3 first or 4x minus 3. It does not matter. When we multiply, the order doesn't matter. Example C, 25 minus 4x squared. This is also a difference of two squares. You have a subtraction sign, and we have 25, which is 5 squared, 4, which is 2 squared. We can factor this as a difference of two squares. You have to be careful with the order. The problem is written in this order: 25 first, 4x squared second. When you factor, keep everything in the same order, meaning I want to write 5 first because that is how we get 25. So make sure you write the 5 first, and then minus plus 2x, 2x. Make sure that you have 5 minus 2x. If this is switched and you write 2x minus 5, that would be wrong. So just make sure you follow the same order. If 25 is first, then write the 5 first. How do you check your answers for A, B, and C? All you have to do is FOIL, or multiply the two factors together, and when you multiply, the middle term will be 0, and you'll get back to the original problem, so you can FOIL. Okay, example D is a little bit different. If you look at these two terms, the first one is to the third power, so it's not squared. This might not look like a difference of two squares, but it is, because notice that if you have a GCF, we need to factor that out. GCF is x. Once we factor out the GCF, x squared minus y squared is a difference of two squares, so we need to factor that. X plus y, x minus y. And that is completely factored. Example E. We have two terms, but pay attention, something is wrong with this example. This is not a difference of two squares. Why? Because we are adding. This is a sum of two squares. We don't have a formula for a sum. I haven't given you a formula for a sum of two squares. So this problem, if you have a sum, is actually not factorable with real numbers. Some of the problems in your book will be a sum, so be careful. Those cannot be factored as a difference of squares. Next example, 128 minus 50x squared. We have two terms, we have a difference. However, 50 is nothing squared. There's no number I can multiply with itself to get 50. The same thing applies to 128. 50 and 128 are not perfect squares. So let's look. Maybe there's a GCF. If we look at this carefully, we notice that there actually is a GCF of 2. We have to factor that first. Now, 64 and 25, those are perfect squares. 64 is 8 times 8, 25 is 5 times 5. So now that is a difference of two squares. Make sure you bring down the GCF when you factor. Notice that I wrote the 8 first because the 64 is written first. Follow the order in which the problem is written. Next, we have the last two examples. So G and H. These two are not difference of two squares because we have more than two terms. These are trinomials. We know how to factor trinomials. These are just a special type of trinomial. They're called perfect square trinomials. Let me show you why. We follow the same steps to factor a trinomial. The order's correct. There is a GCF of 2. Factor that out first. We factor the trinomial inside. Okay, so the signs are negative. Factors of 16 that give me 8 are 4 and 4. This looks just like what we did before, but notice that the two factors are exactly the same. So if the two factors are exactly the same, this is called a perfect square trinomial, and we can write the answer as 2 times y minus 4 squared because the two factors are the same. You can also leave your answer this way, where we just have 2 times y minus 4 times y minus 4. Either answer is fine. Let's look at H. trinomial is in order. There is a GCF of 3 that needs to be factored first. Factor the trinomial. X times x minus minus, and 25 would be 5 and 5 because I have to get 10. This is a perfect square trinomial as well because these two factors are exactly the same, and we can write our answer as 3 times x minus 5 squared.